for the topic inverter. So in the previous part we will discuss about the single phase half bridge inverter. Now we will discuss single phase full bridge inverter. So let's focus on the circuit diagram first. So it consists of one DC supply. Okay, so here it is. Okay, so here actually it is actually Vs, its magnitude is Vs. Okay, so now focus about the circuit diagram. It consists of one, this is your Vs. So it consists of one DC supply, two wire DC supply, and its switches, number of switches are 4 thyristors. 4 thyristors. 4 thyristors and 4 diode. So see, in previous section also we are using diode. So what are the utilization of this diode? What is the importance of these diodes? Because see, only in resistive load there is no need of this diode, but other than resistive load these diodes are act as a free wheel diode or bypass diode. Okay, so let's discuss over here. So 4 thyristors, 4 bypass diodes, 1 DC supply, magnitude Vs, load is connected over here, and here the voltage and current, the given voltage and current, output voltage and output current are in positive direction. Okay, we are assuming this polarity in this direction is our assumed positive direction. Okay, so this is T1, T2, T3, T4, D1, D2, D3, D4. So now discuss about the output waveform. So see, initially we are giving, in this circuit we can't give 2 thyristors in same branch gate pulse in the same time. Okay, we cannot give gate pulse 2 thyristors which are having in the same branch. We can give gate pulse to the alternate one. That means at the same time we can give gate pulse T1 and T2 or T3 and T4, not T1 and T4, because if we give gate pulse of the thyristor in the same branch, then this will be a short circuit problem. This will face a short circuit problem and circuit will be damaged. Okay, so this is the output waveform. So initially Ig1 and Ig2 pulse is given, Ig1, Ig2, for T1 and T2. Clear? So what happens, see over here. So Ig1, Ig2 is given. That means here we get the output voltage waveform like this. So here T1 and T2 is conducting. How? See, when T1, T2 are turned on, the output is like this. Current will flow in this path. So it is in the same direction with the assumed voltage and current direction, output voltage and output current direction. That's why here our output is in the positive part. So it is current, voltage is like this, output voltage, and here the magnitude is plus Vs. Okay, so at this point Ig1, Ig2 is 0, and at this point Ig3 and Ig4 is given, because here thyristor T1, T2 are force commutated. By force commutation process they are turned off, and Ig3, Ig4 given. That means T3, T4 turn on. That means when we give Ig3, Ig4, the current will flow like this. Understood? This is the path. See, here the current direction is in this direction and our current direction is in this direction. Assumed current direction is like this, but that means here these two are in opposite direction. So we get output in the negative half. Okay, then again here the gate pulse is 0 and Ig1, Ig2 is started. That means T1, T2 turn on. So again output waveform is like this, and then again it is 0 and Ig3, Ig4 given. That means again in the negative half. So in this way we got square wave in alternative form. Okay, so from this point to this point, and again from this point to this point is repeating waveform. That means one cycle is, or one time period is like from this point to this point. This is the T. If this is T, from this to this, it is T by 2. Understood? So here T1, T2 conducting, here T3, T4 conducting. So for the time 0 to T by 2, from this to this, thyristor T1, T2 conducts and load voltage is V0 is equal to Vs. And for the time T by 2 to T, that means from this to this, thyristor T3, T4 conducting and load voltage is minus Vs. Understood? So let's get some comparison in between half bridge and full bridge. So the major difference between the single phase half and full bridge inverter is that former, that means the half bridge require a 3-wire DC supply. I told you in half bridge we require 3-wire DC input source, but in full bridge we require 2-wire DC source. Understood? And another difference are over here. Okay, so in half bridge what you see, it comprises 2 thyristor, 2 free wheel diode, and it comprises 4 thyristor and 4 free wheel diode. I told you that in resistive load there is no utilization of free wheel diode, but other than resistive load there is the need of this free wheel diode or bypass diode. Understood? The magnitude of load or output voltage is half of the magnitude of input DC source. That means here our magnitude is Vs by 2. Magnitude of load voltage is equal to the magnitude of DC input source. Here our magnitude is Vs and its half is Vs by 2. Then the main drawback of this inverter is the requirement of 3-wire DC supply, and here this drawback of half bridge inverter is overcome by full bridge inverter. So here we require 3-wire DC supply, but it can be operated by using 2-wire DC source. Okay, and the output power of full bridge inverter is 4 times that of the half bridge inverter. Understood? The output power P equal to what? V into I. So Vs by 2 into I. Okay, so in case of second part, this is Vs into, actually what? Actually, see, in case of power formula is V0 I0, and in case of full bridge it is Vs into I is what? Vs by R, that is equal to Vs square by R. This is the power. In case of half bridge, again P is equal to V0 I0, and here V is equal to Vs by 2 and I is equal to Vs by 2 into R. I can write Vs square by 4R. So what you see, the output power of full bridge inverter is 4 times that of the half bridge inverter. That means if in case of half we have power Vs square by 4R, and if you multiply 4 with this term we get Vs square by R. So this is for full bridge inverter, power is Vs square by R. In case of half bridge inverter, power is Vs square by 4R. So now understood, here the output power of full bridge inverter is 4 times that of the half bridge inverter. So this is all about your full bridge inverter and half bridge inverter. So this is for now. Thank you all.